This is the Dive Into Discovery podcast, where curiosity meets insight, and every conversation uncovers a new layer of understanding.
All right, so get this. Picture this. The world is finally thawing out after this long, brutal ice age, right? Things are looking up, life is flourishing again, and then boom, out of nowhere, temperatures just plummet.
Wow.
The planet is thrown back into this deep freeze for over 1,000 years.
Really?
Yeah, this is the Younger Dryas. It's a real head-scratcher.
Yeah.
It started roughly 12,800 years ago.
Okay.
And we're diving into the research you sent over today.
Okay.
Specifically, this theory about what might have triggered the sudden freeze, and it involves a cosmic impact.
Oh, wow.
Some scientists believe that a comet or asteroid might have just slammed into Earth, causing all sorts of chaos and kickstarting the Younger Dryas.
You've sent some fascinating papers on this, and it really is captivating.
Yeah.
Imagine a massive impact, triggering these catastrophic wildfires,
Wow.
throwing up these huge clouds of dust and debris, blocking out the sun.
Oh, wow.
Maybe even melting glaciers and disrupting ocean currents.
Oh, geez.
All of this could have had just this crazy domino effect, ultimately plunging the planet into that deep freeze.
So we're talking about a planet-altering event.
Totally.
And there's some pretty intriguing evidence for this right here in North America.
Okay.
I was reading about these layers of microspherules, nanodiamonds, iridium, found in sediment cores that date back to the start of the Younger Dryas.
Interesting.
And these materials are often linked to, you guessed it,
Use it?
impact events.
Exactly. And you've also got the black mat, this layer of dark, carbon-rich soil found across the continent. And this points to these widespread fires.
Oh, wow.
Which could be the result of an impact.
Like a giant ancient crime scene, and we're trying to piece together the clues. But here's where it gets even more interesting. The Younger Dryas just so happens to coincide with the extinction of a whole bunch of large mammals.
Oh, really?
Mammoths, mastodons, saber-toothed cats.
You name it.
Interesting.
Could an impact have wiped them out, too?
Now that's where the debate really heats up.
Okay.
While that timing is definitely thought-provoking, it's important to remember that correlation doesn't equal causation.
Right.
Some scientists believe the impact, if there was one, could play a direct role in these extinctions.
Yeah.
Maybe triggering these massive environmental changes that they just couldn't adapt to.
Right.
But there are other researchers who are more cautious, pointing out that large mammals had already been declining for thousands of years before the Younger Dryas even began.
So we've got this puzzle, right? And it seems like we're missing this big piece.
What's that?
The crater.
Ah, yeah.
If a giant rock smacked into Earth, shouldn't there be a giant hole somewhere?
That is the biggest challenge to the impact hypothesis. Despite all this searching, nobody has found a definitive impact crater that dates back to the Younger Dryas. So no crater, no slam dunk.
Well,
does that mean the impact theory is out the window?
Not necessarily.
Okay.
It's a major hurdle.
Yeah.
But proponents of the hypothesis have come up with some explanations for why, or why a crater might be missing.
Okay.
One idea is that the impactor, maybe a comet, broke up into these smaller fragments before hitting Earth, creating multiple smaller impacts spread over a wide area.
Interesting.
Like a shotgun blast instead of a single bullet.
Oh.
Making it harder to pinpoint a specific impact site.
That makes sense.
Right.
And maybe those smaller fragments just exploded in the atmosphere.
Right.
Causing widespread damage without leaving a crater.
Exactly.
Kind of like the Tunguska event in Siberia back in 1908.
The Tunguska event was this massive explosion that flattened trees over hundreds of square miles.
Wow.
Likely caused by an exploding meteor or comet fragment. Left no crater, but definitely made its mark.
Yeah.
So could something similar have happened during the Younger Dryas?
It's a possibility.
It's a possibility.
Okay, so maybe we're not looking for one giant crater.
Right.
But a scattering of evidence from multiple smaller impacts.
Exactly.
But what about those nanodiamonds we talked about earlier?
Yeah.
Aren't those considered strong evidence of an impact?
Nanodiamonds are formed under the intense pressure and heat of an impact event.
Right.
And some studies claim to have found them in the Younger Dryas boundary layer. However, their presence is still heavily debated.
Okay.
Some scientists argue that these nanodiamonds could have come from other sources like volcanic eruptions or even wildfires.
Oh, wow.
Plus, there's always a chance of contamination or inaccuracies in the dating of the samples.
Right, so even the tiniest clues can be tricky to interpret.
For sure.
But what about the massive wildfires that left behind those black mat layers?
Right.
Do those lean more towards an impact or something else entirely?
It's a bit of a chicken and egg scenario, you see.
Oh, okay.
Did the impact trigger the fires, or were the fires a natural occurrence that contributed to the cooling?
Yeah.
It's a crucial question researchers are grappling with.
So we've got all these possible pieces to this puzzle.
Yeah.
A potential impact, maybe a fragmented one, wildfires, a lack of a clear crater.
Right.
Nanodiamonds that might or might not be from space.
Exactly.
Where do we even go from here?
Well, there are other possible explanations for the Younger Dryas that we need to consider.
Okay.
Some scientists believe that massive volcanic eruptions could have thrown enough dust and gases into the atmosphere to trigger a cooling event.
Oh, geez.
And then there's the possibility of ocean current disruptions.
Right.
The way water circulates around the globe has a huge impact on climate.
Right.
And any changes in those currents could have led to the Younger Dryas.
Okay.
We're going to dive deeper into these alternative explanations next time. So, one of the alternative explanations you sent over really caught my eye. This idea that massive volcanic eruptions could have triggered the Younger Dryas.
Right.
I mean, we know volcanoes can spew out huge amounts of ash and sulfur dioxide into the atmosphere.
Right.
And those particles can block sunlight.
Yeah.
And cause global cooling.
That makes sense. We've seen it happen, in more recent history.
Exactly.
The eruption of Mount Tambora in 1815, which caused a year without a summer.
Exactly.
In parts of the northern hemisphere.
And there's evidence of some major volcanic activity around the time of the Younger Dryas. However, it's still unclear whether these eruptions were powerful enough or widespread enough to have caused such a prolonged period of cooling.
So it's possible volcanoes played a role, but maybe not the starring role in this climate drama.
Right.
What about those ocean currents you mentioned?
Yeah.
How could they have contributed to the Younger Dryas?
This is where things get a little complex.
Okay.
But hang in there with me.
Okay.
The way water circulates around the globe, known as thermohaline circulation, acts like this giant conveyor belt, transporting heat from the tropics toward the poles.
Okay.
And it plays this crucial role in regulating global climate.
Okay, so I'm picturing this giant underwater conveyor belt moving all this warm water around.
Yeah.
What happens if that conveyor belt gets disrupted?
Well, one theory is that a massive influx of fresh water into the North Atlantic, perhaps from melting glaciers or ice sheets, could have disrupted this circulation pattern.
Okay.
Fresh water is less dense than salt water.
Right.
And it could have eventually jammed up the conveyor belt.
Wow.
Preventing that warm water from reaching its usual destinations.
So instead of warming things up, the North Atlantic, maybe even the whole planet, started to cool down. It's amazing how interconnected everything is.
I know, it's fascinating.
We're talking about events happening thousands of years ago.
Yeah.
But they still have implications for us today.
Absolutely.
Yeah.
The Younger Dryas serves as this stark reminder that Earth systems are incredibly complex and interconnected. And speaking of connections, the Younger Dryas also coincides with another significant event.
Okay, what's that?
The decline of the Clovis culture.
You're talking about one of the earliest well-documented cultures in North America.
Yes.
Known for their distinctive spear points and their mastery of hunting large animals like mammoths.
Right.
And their disappearance around the same time as the Younger Dryas.
Yeah.
Raises some intriguing questions.
It really does.
Did the sudden climate change and perhaps the extinction of the megafauna play a role in their decline?
A lot to think about there.
It's like this whole web of mysteries tangled together.
It is.
We got possible impact, volcanic eruptions, shifting ocean currents, the disappearance of a whole culture.
Yeah.
It's a lot to wrap our heads around.
It really is.
But how do scientists even begin to study events that happened so long ago?
Right.
I mean, it's not like they can travel back in time and observe what happened firsthand.
That's where the real detective work comes in.
Okay.
Scientists are using a whole toolkit of methods to piece together clues from the past.
Okay.
They analyze sediment cores
Okay.
extracted from lake beds and ocean floors, which contain layers upon layers of material that have accumulated over thousands of years.
So it's like digging through the Earth's archives, page by page,
Exactly.
to uncover the story of the Younger Dryas.
Each layer in those cores provides a snapshot of the environmental conditions at a particular point in time.
Right.
They can look for things like changes in pollen types, which tell us about the vegetation at the time, or changes in the abundance of certain microscopic organisms, which can indicate shifts in temperature or salinity.
And you mentioned ice cores earlier.
Yeah.
How did those contribute to our understanding?
Ice cores are another incredible source of information.
Yeah.
They're like time capsules, preserving layers of snowfall that have accumulated over millennia.
So if we drill down deep enough into an ice sheet, we can look back in time.
Exactly.
Wow.
By analyzing the composition of the ice, the air bubbles trapped within it, the dust and other particles that have settled on the surface, scientists can glean this wealth of information about past climate and atmospheric conditions.
We're talking about analyzing tiny bubbles trapped in ice.
I know, isn't it wild?
To learn about the atmosphere from thousands of years ago.
It's incredible what science can do.
It really is.
And you know those ice cores?
Yeah.
They're some of the strongest evidence for a sudden and dramatic climate shift. At the beginning of the Younger Dryas, they show this rapid drop in temperature.
Wow.
Supporting the idea that something big happened to trigger this cold snap.
So the ice cores confirm the timing and the abruptness of the cooling, but they don't necessarily reveal the culprit.
That's right.
Okay.
They help us understand the what and the when of the Younger Dryas, but the why remains the subject of ongoing research and debate.
It's like we got all the pieces of the puzzle laid out in front of us, but we're still trying to figure out how they all fit together.
I like that analogy. And speaking of pieces of the puzzle, the fossil record provides us with another crucial piece of information.
Right.
You know how life responded to the environmental changes during the Younger Dryas?
We've been focusing on the possible causes, but we haven't talked much about its impact on the planet. What happened to the plants and animals living in a world that suddenly turned colder?
Well, the fossil record shows this dramatic shift in plant and animal communities. Cold-adapted species like the woolly mammoths and the reindeer became more prevalent, while those that preferred warmer climates declined or disappeared from certain regions.
So it was a time of adaptation of winners and losers in this ecological game of survival. But what about those species that couldn't adapt? Did they just vanish completely?
Not always.
Okay.
Some species found refuge in these areas known as glacial refugia.
Okay, what is that?
These were pockets of suitable habitat, often in mountainous areas or along coastlines where they were protected from these harsher conditions.
So like these little islands of life holding out against the cold.
Exactly.
That's amazing.
These refugias allowed some species to survive the Younger Dryas and then repopulate surrounding areas when the climate warmed up again.
So it's this good reminder that even during these periods of dramatic change, life finds a way.
It does.
It's resilient, adaptable.
It is.
It's amazing.
The fossil record provides a testament to that resilience.
It seems like every time we uncover one piece of the Younger Dryas puzzle,
I know,
we find 3 more questions.
That's the beauty of scientific exploration, isn't it? Yeah. It's this never-ending journey of discovery. Peeling back the layers of the past to better understand our world.
So we've been exploring all these different theories, you know, about what might have caused the Younger Dryas impacts, volcanic eruptions, ocean current disruptions.
It's fascinating.
It really is. It's mind-boggling to think about how these events happening thousands of years ago could have had such a profound effect on the planet.
It really highlights the interconnectedness of Earth's systems. Doesn't it?
Yeah, it does. Even seemingly small changes can have these cascading effects across the globe.
Absolutely.
And, you know, the Younger Dryas didn't just impact the physical world. It also coincided with a pivotal period in human history. This transition from hunter-gatherer societies to more settled agricultural communities.
It's an interesting connection.
It really is. We touched on the decline of the Clovis culture earlier. But I'm really fascinated by this idea that the Younger Dryas could have actually influenced the development of agriculture?
Yeah.
Is there evidence to support that?
You sent over some fascinating research on this.
Yeah.
Think about it. The Younger Dryas brought colder, drier conditions.
Okay.
Which would have made it more difficult to rely solely on wild food sources.
Right.
So faced with this challenge, early humans might have been forced to innovate.
Okay.
To find new ways to sustain themselves.
So instead of relying on whatever they could hunt and gather, they started experimenting with cultivating plants, maybe even domesticating certain species to create a more reliable food supply.
That's one of the prevailing theories.
Wow.
It suggests that the environmental pressures of the Younger Dryas, rather than being a setback, could have actually spurred on the development of agriculture.
Wow.
Leading to the rise of villages, then towns, then eventually the civilizations that we know today.
It's like this ancient climate event might have inadvertently set the stage for the world we live in now.
That's a pretty amazing thought.
It really is.
It shows how environmental change, even something as dramatic as the Younger Dryas, can act as a catalyst for human ingenuity and innovation.
And it makes you wonder if this event, with all its upheaval and change, could be woven into the myths and legends of ancient cultures.
It's certainly a possibility.
I mean, a world plunged into a sudden cold snap.
Right.
Resources become scarce, ways of life having to shift.
Right.
That would have left a lasting impression.
Imagine stories passed down through generations.
Yeah.
Tales of a time when the sun disappeared.
Wow.
The land froze.
Yeah, and people had to adapt to survive.
These stories might have been embellished over time, but they could contain echoes of the real-life struggles faced by those who lived through the Younger Dryas.
It's like a bridge between science and mythology, connecting real-world events to the stories we tell ourselves about the past.
Exactly. It reminds us that science isn't just about cold, hard facts.
Right.
It's also about understanding our place in the world. Our connection to the past, and how the events that happened long ago continue to shape our lives today.
We started this deep dive with the question of what caused the Younger Dryas.
Right.
But it seems like the more we learn, the more we realize how far-reaching its effects were.
It's true.
It wasn't just a period of cold weather. It was this catalyst for change. This turning point in Earth's history, possibly even a pivotal moment in the story of humanity.
And the story isn't over yet.
That's right.
Research into the Younger Dryas is ongoing. And new discoveries are constantly being made.
That's so cool.
With advancements in dating techniques, climate modeling, even genetic analysis.
Wow.
Scientists are gaining a more detailed and nuanced understanding of this event than ever before.
It's like a giant puzzle.
It is.
And we're slowly but surely putting the pieces together.
Right.
Each new finding sheds more light on this fascinating period and helps us understand not only the past, but also the potential challenges and opportunities that lie ahead.
You're exactly right. The Younger Dryas, with all its mysteries and complexities, serves as this reminder that our planet's history is filled with these dramatic twists and turns.
It really is.
By studying these events, we gain valuable insights into Earth's resilience, the interconnectedness of its systems, and the importance of adapting to change.
Well, I think we've successfully navigated this deep dive into the Younger Dryas.
We did it.
We've explored the evidence, the controversies, the different perspectives, the lingering mysteries.
It's been a journey.
It's been a truly mind-expanding journey through time.
I agree.
And I hope you found it as fascinating as we did.
It's been a pleasure exploring these ideas with you.
Likewise.
And remember, this is just the beginning of your exploration. There's a wealth of information out there. And I encourage you to continue digging, to keep asking questions, and to never lose your sense of wonder about the world around us.
We've included some links to further resources in the show notes.
Awesome.
So you can delve even deeper into the Younger Dryas.
Perfect.
And who knows, maybe one day you'll be the one making groundbreaking discoveries that unlock the remaining secrets of this captivating period.
I hope so.
Until then, keep those brains buzzing, deep divers.
What did you think of this week's episode? We'd love to hear your thoughts in the comments. Don't forget to join us next time as we dive even deeper. And as always, stay curious, because you never know what discoveries are just around the corner.